Hello, let us integrate the square root of x times the cosine of square root of x. The graph for this function is here, but we will discuss that later. Let us try to figure out how to integrate this function now. And if you remember in the last video, we figured out a formula to integrate functions of the form f of square root of x. And there are a lot of square roots appearing here. So can't we just rewrite this function as a function of the form f of square root of x? And of course we can if we simply put f of x is equal to x times cosine of x. So that's exactly the idea. We will apply the formula for the integral of f of square root of x for the function f of x is equal to x times cosine of x. Remember, to apply this formula, all we had to do was integrate the outer function f twice, which in this case will mean that we will have to integrate x times cosine of x twice. And that's a really easy thing to do. So let's recap. The integral of f of square root of x is just 2 square root of x times capital F of square root of x minus 2 capital G of square root of x, where capital F of x is an antiderivative of f of x, which is just x times cosine of x in this case, and capital G of x is just an antiderivative for capital F of x. So let's just go ahead and do it. We will first have to figure out capital F of x, which is just the integral of x times cosine of x. And that can basically easily be integrated without a substitution, but instead by just doing partial integration. And by the way, I always do partial integration in my head. I don't do it by formula, because back when I was in school, I taught myself how to integrate products of functions. And the idea is, of course, you integrate one of those two factors, but integrating x would be a bad idea, because we will then have to we will end up having to integrate a term of the form x squared times sine of x, but that's of course even more difficult than to integrate x times cosine of x. So the correct idea is to integrate the cosine of x, which will give us a sine of x. So we end up with x times sine of x, right? And if we take the derivative of that, then we will get x times cosine of x, which is good, plus sine of x, and we will have to get rid of the plus sine of x. How do we do that? We add a function which gives us minus sine of x after differentiating, and that's the plus cosine of x, right? If we take the derivative of cosine of x, we get a minus sine of x, which cancels with the plus sine of x, and then we are indeed only left with x times cosine of x. So that's already the first step. We got capital F of x, which is just x times sine of x plus cosine of x, and now we will have to integrate this capital F of x. But this is literally just as easy as integrating f of x, right? Now, instead of having to integrate x times cosine of x, we will have to integrate x times sine of x, which is just as easy as integrating x times cosine of x, right? Because this plus cosine of x factor is also incredibly easy to integrate. So here we go, capital G of x is equal to the integral of capital F of x, which is just the integral of x times sine of x plus cosine of x, and we do the same strategy. We integrate the sine of x, which gives us a minus cosine of x, and so we have minus x times cosine of x. If we take the derivative of this, then we get an x times sine of x, that's okay, minus cosine of x. But we don't want minus cosine, we want plus cosine. So how do we do this? We have to add a plus 2 cosine to the minus cosine, right? And we can accomplish this by just adding a plus 2 sine of x here, because the derivative of 2 sine of x is a 2 cosine of x, and so we end up with minus cosine plus 2 cosine, which gives us this plus cosine that we need here. And so we are all set and ready. We can now just plug in our formula, right? All we need for our formula is capital F and capital G, which we both figured out, so all we need to do is plug in the formula. So now the integral of square root of x times cosine of square root of x is, as I've said, 2 times the square root of x times capital F of square root of x minus 2g of square root of x, and then you just plug in for capital F of square root of x. You just look at what capital F of x is. It's x times sine of x plus cosine of x, but now every time where an x appears, we plug in a square root of x instead, right? And so we get here the square root of x times sine of square root of x plus cosine of square root of x. And the same thing holds for capital G of x. And now we get a minus square root of x times cosine square root of x plus 2 sine of square root of x here. In total, if we multiply this, then all we have to watch out for is the simple fact that the square root of x times the square root of x is just x, right? And so we end up here with a 2x sine of square root of x plus 2 square root of x cosine of square root of x. And then we also have to multiply here this right side by minus 2, and we end up with plus 2 square root of x cosine square root of x and a minus 4 sine of square root of x at the very end. And so in total, we get our solution of 2x times sine of square root of x plus 4 square root of x times cosine square root of x minus 4 sine of square root of x. Again, in total, the integral of square root of x times cosine square root of x dx is equal to 2x times sine of square root of x plus 4 square root of x times cosine of square root of x minus 4 sine of square root of x. And this was a case, I think, where our formula was pretty useful because it was very easy to apply. All we had to do was we had to do two integrals, one of x times cosine of x and one of x times sine plus cosine. And that's just really easy to do. If you do this with a substitution, u equals square root of x, then I believe you will end up having to integrate x squared times cosine of x, which basically is slightly more difficult than integrating x times cosine of x. So I do think that our formula was pretty useful here. And as I've said, by using this formula, we did not have to do any substitution whatsoever. This gives us simply a completely unique way of integrating this function, which is just very nice to see, I think. So let us just verify that what we did is correct. I mean, we did already verify it. This basically, we have proven the formula in the general form, but let's just see if we have plugged in everything correctly and if we integrated these things correctly. And how do we do this? Well, we just take this function here that we got, this 2x times sine of square root of x plus 4 square root of x times cosine square root of x minus 4 sine of square root of x. It's this green function here. I've drawn this here right now. And we take the derivative of it, and we should get our original red function, the square root of x times the cosine of square root of x. We can do this manually, and we will see that we are indeed correct, but we can also let this program take the derivative of this green function for us, and we will indeed end up with this red function. I mean, it already looks like it makes sense. This green function, which is this huge term here to the right, has an extreme value, a maximum, at roughly 2.5. And this is exactly where square root of x times cosine of square root of x has a root, right? The square root of x times the cosine of square root of x has a root at pi over 2 squared, which is just pi squared divided by 4. And I mean, pi squared is almost equal to 10, and so pi squared divided by 4 is almost equal to 2.5, and that's where this root is, and that's also where this extreme value is. And it just makes sense. Square root of x times cosine square root of x turns negative at this point, and this is where this green function here is starting to fall, and it's falling more quickly and more quickly, and in fact this red function here is also getting more and more negative. So this already looks like it makes sense. So finally, let us just take the derivative of this function here, dy dx. We will draw it in purple here, and as you can see, this purple graph, which is the function graph for the derivative of this green function, is exactly the same as the graph for this red function. And so we were indeed right. Hope you liked this video, and I will see you guys in the next one.